Hello, everyone. Hey, finally got sound working. So today is part two of um, trying to attempt the Kaggle gendered pronoun resolution challenge. Last time we went over the competition, reviewed the data, reviewed a submission, and then we started reviewing BERT. It's just the idea I had to try to use BERT as a solution for a submission and just see what kind of results that we get. And the exact solution pattern that we landed on was actually the SQUAD data set. So posing the the data as a question answering pair and letting the model generate an answer. So for instance, given an input sentence as text, ask the question, who does she refer to? And see if the model will generate either the A selection or the B selection. With respect to coding, we were able to load the models, actually download the data from the GitHub repo, and then we started actually getting the required data format correct. So in order to use the SQUAD model, we need to actually have SQUAD examples. So this is a copy paste from the actual GitHub repo, and we were in the middle of that. All right, so let's get started. Pick up where we left off. So we need to add the document tokens. So if we go back to the SQUAD example, there's these for loops where you have for a paragraph, you have doc tokens that are generated. You actually need to run something like this on the paragraph text. All right. So here, for paragraph text, creates doc tokens and chart a word offset. Doc tokens and chart a word offset. And then the chart a word offsets, just putting back together what I remember, how it actually works. So first let's just put together this doc tokens given this paragraph text. So we can pretty much copy that. We have paragraph text, and then for each character and paragraph text, check if it's white space, and previous is white space, else so for the next time it comes around, if the current character is a white space character, then what you do is you just append that character to the chart to word offset. However, if it's not a white space and the previous was a white space, then you append that doc token. And just to refresh ourselves, we can actually keep that sample. No, go back. Oh, of course, I lose my context. All right, so let's quickly execute needed code. And let's actually, dang it. Should probably take off scrolling with 2 fingers. or changing changing pages with 2 fingers on the mouse pad. All right. So here. So we have, let's get an example paragraph text. So if we do the first, one example. iLoc, the index location, and then text. So the iLoc 0 gives the first row. We want the text attribute. All right, then we have text attribute. Now we can use that previous code that we were looking at. Not standard. It looks like the code was using 2 characters versus a tab indent. So the parser in this Jupyter notebook is getting confused. Previous is white space is false. There. And then in this code, paragraph text equals. And then we can go ahead and print the chart of word offset. Print the doc tokens and see what shows up. Is white space. Needs to be defined. Touche. All right, so they need the function is white space. Maybe I can use the actual code. Right, instead of importing run classifier, you can import run squad, which is the name of the file that we see here. So let's go ahead and importing squad. Interesting. Run squad that is white space. Oh, it's an inner function inside of read squad examples. All right, so that's not, is white space is not publicly exposed. All right. So here we have the doc tokens and the chart of word offset. So we actually do need the doc tokens. Damn it. I'm actually going to turn off that 2-finger swipe. All right. That was really annoying. Probably just incentive to save often. Oh, it did save. Oh, thank goodness. So we can go ahead and turn this example. Oh, it does keep the context. You can tell by the 42. So let's go ahead and turn this into a function. Get tokens and paragraph. And just input everything. Oops. And you can just go ahead and return tokens. Cool. So now we have a function that will given paragraph text, it will actually give us doc tokens. So we can go ahead and say train df tokens equals, and then input is which column is the input text. So text column, apply lambda function, and on each instance of the text row, of the text attribute for that row, we're going to pass it as paragraph text. And go ahead and call get doc tokens. On that paragraph text. And now it's a little bit longer. And then you can see doc tokens, she had non-speaking roles. All right. So this is a lambda function. This is a apply lets you use a lambda expression to apply a function to each attribute that the apply function iterates over. All right, so after add start number word, add start word number of answer text. So how is that done here? So start position. Oh, of the answer. So if the word, so if is impossible, or if not is impossible. So if it is possible, then we can go ahead and try to get the start position. Right, so if not is impossible, chart or word offset is the answer offset. Here we have an answer offset. Chart or word offset. So if you look at what the chart or word offset looks like, it's actually the character. All right, so for instance, if we were to look at let's go ahead and remind ourselves what a row looks like. So if we were to look at the A offset inside of, so if we were to do 156, it tells you 29. And then if you look at 29, the season, which is incorrect. What did I do wrong? Let's go ahead and print paragraph text. We're going ahead. Oh, I know what's happening. This doc tokens and chart word offset is from the lambda function and not from the execution of get doc tokens. So I wonder, paragraph. Right, because paragraph text should be she, and this one is he has. She had non-speaking roles. All right. So we're going to put above this cell block because that I like to keep the code that I need that is necessary for the next block before. And now this turns into my scratch area. All right. She had. All right. So now we can look at 156. 156. So the 156 character, right? This A offset refers to the 28th word, and the 28th word should be Linda. All right. Interesting part that it doesn't have an ending. Because what I want to do is what's this answer length? Answer length is the number of words in the text. Hmm. I wonder if we can generate multiple columns from Python lambda. Multiple lambda function lambda and multiple columns from the function. Yeah. Is that possible? Building off, you can do the assignment in one passing using df merge. df dot apply. So you have a data frame, a virtual data frame that you merge with the apply on the text column. And the lambda function returns a series. Index true, right index true. So other examples are using zip. Dot map powers. Oh man. No, I really like that first one. Really like this first. Really like this first solution. DF merge series. All right. It looks like is impossible should be before, because I want to use is impossible inside of this code here. So it should really just be like get squad from the paragraph text. So then what we're going to return then is a PD series. Return a PD series. Cool. Doc tokens. Doc tokens. And yes, we're going to apply text. So get squad attributes. Read paragraph text. Read. What really happens is you want to do like df temp. Since we're going to be using multiple columns at the same time, instead of it being pure lambda text, it's now a, instead of just processing the text column, you're actually going to pass in the entire row beforehand. So if I can just a row. What does this look like? Oh, and the rest of it is merging. So you want to merge the result of what you applied with the data frame that you created. Original data frame merge with the result of applying this function. And you're going to say left index true, right index true. All right. Let's see what happens. Of course, get squad attributes is not defined. Agree. Occurred at index ID. Yikes. So one thing we want to do is, invalid syntax. An integer is acquired. Text occurred at index ID. I wonder what this row looks like. TF Can you print so printing the road does work, so I don't understand why. Printing, oh no it doesn't. So the apply syntax errors. Silly syntax errors. Okay. So they did print the row. So what does that all look like? Not really sure what I'm looking at. Okay. Data frame apply. To each column or row. 0 or index. Now I want to apply functions to each row. So axis should equal 1. Default 0. So apply on axis equal 1. Yeah, that's what I expect to see. All right. So now that sweet. So now that generated doc tokens. What about chart of word offset? Sweet. And then let's keep on going. And then the next thing, the rest of the code is about if is impossible. So if not is impossible. Alright. So is impossible. Is possible. So what is we want to pass off is impossible. Row is so everything is singularly indented. If actual text. TF volume. And what this will actually do is the start position So if is impossible, the answer. Ooh, interesting. So maybe we should just patch the whole row. Paragraph text equals row text, and row is impossible because we keep on pulling stuff out of the row. And no need to make this any more complicated than it already is. Right. What else do we need? We need the answer. Right. So this is original answer text. Wait here a second. So that's derived by whether the answer is A or B. So the answer is like this. If A co-ref. Alright, the answer. And if check each of the co-refs. If A co, the answer is A else. Since we know it's not impossible, the answer is either A or B. At this point, I'm going to make an impossible scenario where it is nothing. Yeah. So the original answer text. Wait, what is this? What's this answer text? So if we're interested, we go to the raw dead JSON and see what this all looks like. So if we look at answers, answer start. Oh, interesting. The answer start is actually the offset, and the text is the actual text. All right, so let's look. Oh, so we actually don't have answer. So what you have is this original answer text. And offset answer row and B offset. And the rest stays the same. And what I need is, oh, I don't have the question text. So the ID question text is to be determined. The doc tokens is doc tokens. Okay. The original answer text. Cool. You have the start position. And then the end position. It's impossible. Oh, that's already done. All right, cool. So that's that. Continue not properly in loop. Not properly in loop. So where was it before? Alright, let me just get rid of that for now. Success. So now, yeah, processing is going to take a long time now. I wonder why this is taking such a long time to just load. What happens if I wanted to? Oh, my connection failed. My internet out? Nope. Come on. Come on. All right, there you go. Oh, it crashed. Let me go ahead and save this. Commit. Yeah. Creating function shouldn't take any time, so I knew that was something bad was about to happen. What is the issue? Tokenization is not defined. Created index. Ooh, interesting. So is there a tokenization? Where does that come from? It does import tokenization. All right, so looks like it's time to import all those things. Copy paste everything that we got. We'll turn it on when we need it. That will just make sure that the code is smooth. All right. So instead of head, we'll create the full data frame. I'm assigning it to a new variable because I don't want to overwrite the original data frame number. Oh, interesting. Numbers are all different. 2,000 rows. Cool. So now, this can all go away. Yeah. All this code together. So now, let's create a train test split. All right. Train. All right, so we have a train and test, so you can put this all together when we need it. Yep, see this create examples. So train lines, train examples, label lists. So this create examples should return, ooh, interesting, a GUID. So let's figure out what's going on. Generate data for the BERT model, set type. Oh, so the create examples is called twice, one for train and one for test. When it's test, the label is automatically specified. So let's check what create examples is called. Train. Oh, and then here test. Predict examples. All right. So let's go ahead. Instead of train lines, we're going to create squad example. And then if we look in the original BERT code, where is it? All right, so BERT squad. Read squad examples. Yeah, so read squad examples automatically returns a list of examples. Examples.append example. All right. So we should do this stuff. Down here. Ooh. So I have the entire train. All right. So I want to call, instead of train lines, train. So now this is the entire row. Don't need labels. So I go up. So this is the set type, examples. Oh, it's zipping it together. Oh, interesting. What we can actually do is use pandas again to apply a function from a row. Because it's not a single row, it's all the rows. Run classifier dot put example. So this is actually run squad. All right. All right. So for in rows, row ID visitors plus line 30. What are you complaining about? There's no end. The end. Here's 2J. In the run classifier. I agree. Train is not found. I'll believe you, my friend. Right. I expect an error. I expect an error around here. Question text. Question text is not defined. String indices must be integers. Oh, here you go. So here we can actually ooh. If we were to train, which should be okay. Trying to figure out why printing row only gives ID. Seems to be some like index iteration. Yeah. Let's try why Let's go ahead and do a run. Squad example. Row type. So we'll have row ID, comma, access. One each row by row. And then the question text is, which noun does pronoun refer to? So alright. Alright. Ability. So this will be which pronoun, which noun does pronoun refer to? Alright. And you have row dot tokens. You have pretty much the same things. Let's say sweet. And you return this. So what noun does his refer to? The answer is nothing. Apply. Create squad example. Row. Train. Oh, train is the name of the thing. So I guess I don't even need set type. Row. Set type. That's all I used. And how is this all used? There's a create example. That should be it. Delete. Run classifier is not defined. I agree. Run squad. So the next instance is run squad. So let's go over this code here. Some initial variables. Label list. Don't need that. TPU configuration, model function builder. Oh, that would probably be different. So let's go ahead and see. How is this used? Sweet. So config nothing about labels. There is a checkpoint. There is a checkpoint. There is a learning rate. Num steps, warm-up steps. Use TPU. Use one-hot embeddings. Estimator. TPU. Model function open big batch size. Right. What happens next? Sweet. Draft saved. Save it again. Let's go ahead and commit. Return to editor. And what is happening? So this is all just setting up the model. Yeah, that should be done, exactly. After you set up the model, you can just go ahead and train the model. It's called, BERT examples of features. Examples looks like tokenizer. No need for label lists. Docstride. What's that? Docstride. Turns out Docstride is 128. Okay. Sequence length. Okay, so Docstride is 128. Next query length. 4. It's training. It's true. All right. True. Output function. Process feature is not. Oh. Write an input feature to the TF record writer as a TF train example. Number of features +1. Ooh. Output function loads a data file into a list of input batches. Output function. Well, that is a lot of code. So I wonder, so this is calling every function. I wonder how output function train writer. All right. Output dir. There is. Is there an output dir? Oh, there is. All right. So let's do that. And after that is train writer. Process feature. Train writer. then we have the input function builder. You again have the train writer.file name. That's sequence length. Pretty much using the run squad. Run squad's a very awesome resource to just get you up and running. Here. Estimator.train. Train input function. Num train steps. All right. Feature writer is not defined. Touche. Class feature writer. So this should be squad.featurewriter. All right. Squad. Oh, is not defined. Correct. Because it is full uppercase. All right. So is training true? No such file or directory. Yeah, I know. I want to create it. Feature writer. Yeah, so TF Python.io writer. New. So maybe they want you to create this file first. I'm going to go ahead and cheat. The way you create a file is called touch. All right. So if you just say oh, because it doesn't exist. Outputs, model repo outputs doesn't exist. How is this outputter used? Repo outputs. There's right there, model repo. OS. Oh, it's model repo. Oh, interesting. There is no dir call to outputs is the issue. All right. So I'm using all that. So, maker. All right, now we're cooking. So which noun does she refer to? The 2016 European Championship Athletics. O'Rourke finished joint second. Token to orange map. Token is max contexts. Answer Derval. Does Derval exist? Just checking out the input or output of the model training. See if I can figure out. Make heads up. What's going on? Doop, 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 doop. Lots of printing. All right. Input function. What is this input function builder? All right. Saving checkputs. Don't think it's actually started training yet. I think what's going on is, yeah, it's just initializing the model, loading the checkpoint. Oh, interesting. Yeah, we definitely want the gap answers. Oh, so this is so I don't have to use GitHub in order to get the answers. Oh my goodness, did I just kill everything again? Oh my goodness. I think I'm going to commit one more time just to make sure I don't lose any of my progress. All right. I wonder if I can. Oh, man. $11. Yikes. Run squad is not defined. Touche. Run squad is not defined. Mission. 104% CPU. Oh, GPU off. That's interesting. So I definitely want to turn the GPU on. really big difference between CPU and GPU. All right. Let's check if, all right. Is if TensorFlow GPU is used. Check GPU. Inside the Python shell. No. Yes. Let's check if GPU is being used. I'm rolling. You know how you do in a notebook, right? When you execute it multiple times in a row and keep on getting the same results. Or consistent. That's all the time I have for today. I'm going to try to get results. And if this doesn't get results, I'll just pick it up from here next time. All right. Signing off. Bye.